I'm Jackie Garofano, Chief Technology Officer at CCAT, the Connecticut Center for Advanced Technology. We've created a series of videos on how to use model-based definition. Now, Nasir Manin, Principal Engineer at CCAT, is partnering with technology providers out there in the ecosystem to show you how to incorporate their software into your workflows.
Today, we're going to be looking at how model-based definition can be used to create automated first article inspection reports. We're going to take a look at a couple of the different model-based definition neutral file formats, and we'll see how we can use that to automate processes. Today, we have with us Lyle Fisher from CatVidia. He's going to be walking us through MBD Vidia software.
Thanks, Nasir. What I'm going to share with you today is a model-based workflow for first article inspection. And this is kind of the state of the art, what a lot of companies who are adopting model-based are doing, because first article inspection is something they're already doing. And this is an easy, quick way to get into this and get a quick return on your investment. So I'm starting today with Creo. Now we support all the major CAD systems, but for this demonstration purpose, we're going to start in Creo. We begin our workflow with an MBD. So here's a Creo model. You can see they have different combined states. We got the front view, the left view. I mean, this is all done, authored in MBD. Inside of Creo, we have what we call add-in called MBD Connect. And what this does, this connects us to the MBD world. So I have two options here. We have QIF export, which is QIF is a quality information framework standard. That's an ISO standard for MBD, and Step 242, which is also an ISO standard. So we support both workflows, but for today I'm going to start with Step. We're just going to export this out of Creo, as you said, into a neutral file format. And this is what we're going to use downstream. All right, so that's been exported. Now we're going to go into our product called MBD Vidia, which is a tool we use to visualize and prepare MBD models for first article inspection. So let's open this step file and take a look at it. So here's our step file open up in MBD Vidia. So one of the key things about this whole model-based process is we really strive for semantic PMI. And what I really mean by that, there's human readable and machine readable. So if you look at this definition here, is you have a couple feature patterns and size, location. As a human being, you know which holes you're talking about. But to consume this downstream, the software, like a CMM program, needs to have those features clearly defined, semantically correct. So we have a tool here called what we call MBD Ready Check. So I'm going to open a panel here so I can look at this information. And I'll size up my screen a little bit. And we're going to do what we call MBD Ready Check. Now this does a semantic check of the MBD. And you can see in red, we have things here that are not properly defined. So our summary basically says we have 46 annotations here. 5 of them have problems. Our MBD score is 89%. So now this is a key part of this workflow, because you have to author this properly to really take advantage of the MBD downstream. So let's go look at some of these examples here. So for example, datum A. If we look at datum A, our software is telling us that it's linked to opposite lines features, but really the correct definition for this is it's a datum, so it should be assigned to the cylinder here. So we rotate this slightly, you'll see, if I zoom in there, you'll see the red edges is what it's attached to. And so our software is intelligent enough to go in and say, look, it's obvious it should be attached to the cylinder. It's the only thing that makes sense here. So here, this can go, we have companies that use this to go back to engineering and correct their models, so they have a correct MBD model. And the other use case here is there are people who do an inspection. They need this fix, but they can't always go back to engineering and have it done. So this tool works for both sides of that equation.
Great. Yeah, so that's amazing that in a single button click you identified all the issues. You wouldn't have had to discover that post any kind of process. Instead, you're getting it right here up front. And the nice thing is that you're actually showing the recommendation on what it should be connected to.
Right. We still leave it to the user. And I always tell people, you know, someone has to fix this. Right? If you don't do it here, then the CMM program, he's going to spend extra time and money
Yeah.
getting this all sorted out before he creates the CMM program.
Yep. Yep. It'll hinder that automation, if you will.
Yep. So we can just right-click us and repair that, and now this datum will be attached to the cylinder, okay, and it's corrected. So likewise, we can correct all this stuff. We can do it automatically. Just a simple example of one of the key steps of this workflow.
Mm-hmm.
Okay. So now we also work with QIF, and you'll see that the QIF file looks exactly like a step 42, 242. Mm-hmm. In fact, they've been harmonized. They're pretty much identical formats. So here's our information, all the annotations, just like in step 242. Yeah. Now this one's already been cleaned up with the ready check function, so it's ready to go for downstream inspection. Yeah. What we do here is we have a tool to do the ballooning. So this button here gives us our bill of characteristics for this part. Now the bill of characteristics is simply a tool for you to create your inspection plan. What do you want to measure, and how do you want it measured, and what do you want reported on? So you'll see here in this column we have the tags, the check marks. I'm going to go to the front view for a second here. So remember we were talking about proper semantics here? Okay, if we look at this 4x feature pattern, you can see the representation in the bill of characteristics. If I click on each one of these items, you see it's 9.1, 9.2, 9.3.
Oh yeah. Mm-hmm.
Because you need to inspect those individually. Yeah. And the beautiful thing about this standard is that you'll notice we have this unique identifier over here. It's called a universal ID. We'll call it a Cupid. Mm-hmm. That's a unique identifier that has traceability into it. So when this data gets sent downstream, maybe to NetInspect or to a CMM program or to an Excel form, balloon 9.4 is going to be the same balloon for everybody.
I see.
And that gives you the basis for harvesting the measurement results because everybody's measuring the same feature, and the quality engineer can look at that and say, okay, I have all this information, whether it came from a CMM, and it pulls it all together.
That's that link right there.
Yeah.
For each feature, you have a nice link.
Right. Okay, so from here, I'm going to publish this to NetInspect. So this will take all this data, it'll upload it into Form 1, 2, 3 in the NetInspect cloud. Okay, and I'm logging the NetInspect with my login and password. Okay, so as you see, Form 1, Form 2 are here, but the real crux of this is Form 3. Now you'll notice here that this is the balloon number that we ballooned. And this is the requirement of the characteristic. You can put results in here. This is a very nice program for managing first articles, and a lot of aerospace companies use this. This QIF model that we have here, okay, we ballooned it. We sent it off to a CMM program, and they did their inspection. Because it was semantically correct, they could quickly create the program, and they can output results that we can consume. So that's the next part of this demonstration. There's a tool here to upload CMM results. And I have some here. So this is a QIF file, a QIF results file that was actually exported from a CMM. Drag them here, upload them, and with the unique identifiers, again, remember we talked about the Cupids?
Yep.
Everything matches.
I see. Yeah.
So you'll see all these things turn green, which means balloon 7.1 or is matches 7.1, and you can simply submit this information to NetInspect. Okay? And now what you see here is the measurement results in Form 3.
Yeah.
Green means you're within 50% of the tolerance. Yellow means you're 50% on the other side of the tolerance.
Okay. Yeah.
And there is one that's out of tolerance that's red. What have we done? We've started with an MBD. We exported to QF. We did the ballooning.
Yeah.
We sent it out for inspection. And this company, maybe they use NetInspect. And NetInspect, somebody had a CMM. They uploaded results. And so now there's data available to the quality engineer. So if I go back to MBD and I'm going to import those results from NetInspect, but more importantly from the CMM.
Yeah.
And here you have them. You can see my results. If you click on these now, each one of these holes has a measurement result attached to that.
Oh, that's a very nice visual. Yeah.
It's more than a visual though,
Yeah.
because yes, it's in our software, but more importantly, the QIF standard, it has this, you see the plus sign there? It actually has the results here stored in the format.
Oh,
that
wow.
means
Yeah.
that means you can keep accumulating data
Yeah.
into this QIF model from other sources. I also have another tool here that we use to do this, and we create a 3D HTML report. Because if you look back at NetInspect here, you know, you don't have any visual of what this is.
Sure. Yeah.
So if we go to NVIDIA, we create a 3D HTML report. Okay, we'll save it here. So this uses 3D HTML, and the advantage of this is that you can open up this bill of characteristics in any web browser. So it pops up a window here, but I'll go to my web browser and show you what this looks like. Here's the HTML file. You just open it up, and now alongside my NetInspect first article, I have this. So this is something you can rotate. We have the bill of characteristics here, so we have the model tree, we have the views. So if I want to go back to our front view, when I click on this, see it'll highlight the rows here.
Oh, nice. Yeah.
So this is I can rotate this a little bit. I can click on each one of those holes. We provide this for companies that people on the shop floor, maybe they're not computer savvy. You don't want to have a seat of a CAD system or our software. You just want to look at it. So as long as they have a browser, they can open this up and look at it.
Very nice way to collaborate between the inspection, the designer, all the different departments within a manufacturing company.
And if you see here, we've also got the results were uploaded too.
Yeah.
So you can actually look at the measurement results as well.
That's actually a very nice way to very quickly have your customers view the status of a part.
Absolutely. And you don't need to be a genius to look at this.
Yeah.
All right. So a couple more things I want to show you. I also prepared an export of this to an Excel report. So let me show you what I'm using. We have some different forms that we use. I'm going to open this one. This is called the Initial Sample Inspection Report. And it's something we provide with our software. You can see we have all these characteristics here. And we have results for 5 articles. Okay? So the way this works is from our software, you create your inspection plan. You send an Excel form, and somebody puts results in.
Sure.
Now we have results. We can bring them into NVIDIA. Again, add them to what we have here.
Yeah.
And I use the import of this. And what you'll see here is we're accumulating data here now. So now when I click on this, I've got more results. These results can come from different suppliers, different runs, different, maybe something happened during the process. They had to change a tool.
Yeah.
This just gives you a way to put this all together. It's the round trip of MBD. It's taking things downstream, bringing them back upstream.
Nothing in paper, everything digital, a couple of mouse clicks, and you've got a good visualization. You've got your CMM results stored in a central location. You have the ability even for your customers to view that data. This is really, really powerful. Particularly like the fact that you can, if you're doing multiple runs, one of the biggest problems is to try and do some trend analysis on a feature. And this is a very nice way to visualize what might be going wrong and when you should be changing your tools out.
Yeah, actually, that's a good point, because I'm showing you the measurement values here, but we actually can show you an individual's chart.
Oh, nice. Yeah.
We can show you moving range. We can show you some CPK. So you can really start to look at this data and start to understand what it is, what you're getting.
Yeah.
So that's another nice thing that you can do with MBD. I can show you what we do for 2D ballooning, because the reality is not everybody's getting MBD. You talk to a lot of suppliers, how much MBD you're getting, and we're starting to see some. We still live in a 2D drawing world.
Yeah.
Sure. So our customers asked us to provide a solution for 2D ballooning. And we kind of reluctantly did it because we're an MBD company.
Yeah.
But what they wanted was to use the same kind of workflow for 2D. So let me show you how that works.
Sure.
I'm going to go to a 2D layout now. And what I'm going to do, I'm going to take a 2D PDF. And I'm going to drag and drop it in here. Okay, so we've got a 2-page drawing here that we want to do first article inspection on. So the first thing we give you the possibility to do is to, I'll go back to page 1, we'll generate views for this. And the viewers, we give you the possibility, we color code different views.
Yeah.
So in this case, we want this as a separate view maybe, so we can disconnect that, or we can connect things. And we save these as views, and they show up here in our tree. We're basically building a QIF model out of 2D data.
Wow.
Let's go to the next page. We'll generate our views here. These are nicely organized. You know, some TLs have annotation that slides way over here, and you have to separate them out. But this is pretty good. So we'll save that. Then we'll go in here, and the next step is now we got our views here. We're going to do what we call auto capture. This is using OCR technology that will basically look at the text and balloon it based on, and interpret the text in there.
Oh, great. Yeah.
So we've got our results. We can start looking at these. You can see we have an editor over here. I can zoom into this. So you can see we've captured this. We can edit this if there's a mistake. We can approve it, go to the next one, and just look at each one of these to make sure that they're correct. But the important thing here, I guess, is if you look at the bill of characteristics, you'll see we've got all these characteristics here with the balloon number. So what can we do now? We can go to Net Inspect. We can upload this to Net Inspect. And then you can put results in, and you can actually pull the results back in. So I'll show you, I'll use a completed one here. So this is a completed drawing. You can see everything is green. I'll go to page 2. Okay, so we have all this information here. Then we can simply export this out to AS9102 form, and we can also pull in measurement results. So that's a little bit of the 2D. I mean, we allow you to balloon to external documents for specifications, but the main idea here is that you've got a tool that works with model-based and actually lets you work in a 2D world in using the same workflow and tools. The only thing that's missing from the 2D workflow is an MBD. Yeah,
that's a very powerful way in the way in which you do it. You're capturing all the measurements using OCR technology. I mean, that was fantastic. It's automatic. It's pretty much a button click, and then, as you said, just go through and check it. Saves a lot. I mean, that's a big time saver to digitize, you know, printed documents and capture it in this kind of a digital form, so that you present it in such a way that you can reuse it.
Yeah, and it gives companies that want to adopt MBD a tool they can start with, and when they start getting MBD, they have a familiar tool. So the learning curve is very simple, very easy.
So thank you, Lyle, for walking us through MBD Video and showing us all the capabilities that the software has to offer.
I appreciate the time. Thank you.
So there you have it. Using model-based definition can be a huge time saver. It allows you to do literally push-button operations. What would take hours, you saw, got compressed down to minutes. You have your first article inspection report in a button click. You have your CMM results in a central location, and then you can pull that back in. It's all in a digital workflow. Absolutely drive efficiencies at your businesses.
It's important for your company to become an early adopter of using model-based definition. The reason for this is because the Department of Defense is already flowing down requirements into the industrial base to do so. Wherever you are, there are a lot of resources out there to help companies start their MBD journey. If you're not sure where to look, we're CCAT, and we're here to help.